Hi, my name is Colby Wright, and I will be presenting my senior project, which is a sailboat trailer. My ultimate goal is to design and build a trailer that is capable of hauling a sailboat, specifically a lightning sailboat. And I would also like to, by the end of the spring semester, register, inspect, and be able to tow this trailer down the road with the sailboat. 7 years ago, I was at Boy Scout camp, and that's where I first learned to sail on a little 12-foot sunfish. It wasn't very good, but I just got the basics and the concept of how to sail, but I had a blast. This past summer, at my last internship, my boss, a couple weeks after working for him, asked me if I knew how to sail, and I told him, not really, but I get the gist of it. And he asked me to come up to Lake Ontario and start sailing with them. They raced every week on 30-foot sailboats. So I ended up going, and I had an absolute blast. And from every week on, for the rest of the summer, I sailed with my boss. I ended up about halfway through the summer getting my own sailboat, a lightning sailboat. Most sailors know this kind of boat, as most of them have either had one or have sailed one at one point in their life. I told most of the sailors who sailed with my boss that I got one, and they were all very excited, as that's where they all started too. Each lightning sailboat is 19 feet long, 6.5 feet wide, has a 26-foot tall mast, and the hull weighs 700 pounds. Each lightning also has a number imprinted on the center board. They're up to 15,000 now, because they still make lightnings today. The number on this boat is 3822. It is. I looked up what sailboat it was and when it was made and all the facts about it, and it was one of the first fiberglass sailboats made back in 1951. Lightnings were actually designed and first built in 1938 out of wood, and later transitioned into fiberglass. And it was actually designed and built on Skinny Atlas Lake here in New York. Like I said, it was first built in 1951. It was registered for a couple years, but the location of this boat specifically has been unknown for the past 60 years. As you can see in this picture, both the boat and the trailer are a bit of a fixer-upper, but that's what makes it nice, is you get to work on it and then you're proud of your work, show it off. I considered just renovating and fixing this trailer, but I thought to myself, designing and building a trailer specific for this boat would be a great senior project. Steps to follow. First, after approval, the first step is to start designing. You start with the general dimensions, given off the boat as how wide you want the trailer and how long and everything like that, and a good idea of what I want the outcome to be. This includes trailer configurations and picking one to start, as there are many different configurations. Boat trailers either have rollers or perpendicular or parallel supports. There's lots of different options, so it's best to just pick one, follow the steps, and you'll end up with the best one at the end. After that, the next step is to start performing calculations and analysis on the trailer and make changes as necessary. Changes will come about as, just starting to build a trailer, and after performing calculations, if one thing doesn't work out, you need to make the according changes and just keep on working until everything works out. This may take a while, but it's worth it, as a well-designed trailer is much better than a poorly designed trailer. A poorly designed trailer might fail. Upon completion of the calculations and analysis and coming up with a final design for the trailer, fabrication starts. And it's best to start with the outline of the frame. Again, during fabrication, testing is very important, and changes will probably need to be made, but this is to ensure that a better trailer will be made. Test these components during fabrication if possible. Post-completion of the trailer, the next step is then to register and inspect the trailer and get it on the road so we can start sailing. I'll be utilizing much of what we learned throughout MDP and MSD, as well all the other professors have taught me here at school. I'll be applying all sorts of different calculations and comparisons in each aspect of the trailer. So framework, welding calculations. The steel frame will need welding calculations in order to determine the bead size of the weld for a structurally sound trailer. Tongue weight calculations are necessary in order to find out where the axle is best placed on the trailer. We want the weight in front of the axle. That way, when you're towing it down the road, if you hit a bump, it doesn't sway back and forth. And the receiver on the car can handle the weight of the tongue weight of the trailer and sailboat. Lug design for safety chains. This is very important, as if for some reason the trailer fails and it needs to rely on the safety chains, we don't want the chains to pull the lugs off the trailer. So these need to be properly designed so that if a failure for some reason occurs and the safety chains need to come into play, that they work properly. Winch attachment. It is needed to calculate where the winch will be in order to best determine the location of it to be most effective. Because if the winch is in a bad spot, you won't be able to pull the boat up onto the trailer all the way. Bolting calculations. These are very important and will mostly be utilized with attaching the receiver to my car. We want the receiver to stay on the car and not have the bolts fail, otherwise we lose the boat and trailer and receiver to down on the road. Integrated ladder. It would be ideal to integrate a ladder into the frame for ease of access in order to get on top of the sailboat. When you're launching and taking the sailboat out of the water, you got to get up on top and take the mast in and out and unhook the cables, and you find yourself climbing all over all the time. So a ladder, an integrated ladder would be very useful. Buckling calculations for the mast holder. Depending on the design, if there will be one rod in the front for the mast and then tied to the boat in the back, or one in the back depending on how the design works out. Like I said, there's many different configurations that will need to be worked out to figure out the best one. But the buckling calculations need to be done in order to ensure that the mast won't crush the steel. Axle. Bearing calculations need to be done for the wheels on the axle if they're not already on the wheels, or if they don't already come with the wheels. Suspension. I need to determine which type of suspension will be best for the trailer and the sailboat. Shock or leaf spring, which one's better and why, and choose the correct one. Shearing calculations need to be done, especially if leaf springs is what I end up going with because they're connected with pins, and we need to make sure that those don't fail. Electrical work. There isn't too much electrical work to do with this project, but there is just a little bit. This includes the trailer light wiring harness, or trailer light wiring and installation, choosing either LED or a conventional bulb, and figuring out how to wire that. And the car also needs a wiring harness installed, as there is no wiring harness or receiver on my car right now. SOLIDWORKS analysis and simulation. SOLIDWORKS is a very powerful software that we have used throughout our curriculum here at Alfred State. It allows us to perform analysis on I will be able to perform analysis on the trailer and trailer parts, such as a stress analysis or a flow simulation. Stress analysis will be used on the steel members of the frame to ensure that I will choose the correct size when designing the trailer, and I'll be able to build after the stress analysis is done using the correct size. The flow simulation will be done and will help aid in choosing the correct frame design from the beginning. Like I said, with rollers or perpendicular or parallel platforms, a flow simulation can be done in order to ensure that the most efficient trailer is built in terms of drag. We can use flow simulation to figure that out. During this project, I will utilize what I've learned during my time here at Alfred State and incorporate all of what my different professors have taught me throughout the years. This project will include the design, calculations and analysis and fabrication of a sailboat trailer, specifically a lightning sailboat, like I was describing. This project is to be completed by the end of the spring semester of 2017. It is my goal to have a registered and inspected trailer that I built on my own and can tow down to the lake to start sailing. Thank you.